Alright guys, we're going to get right into it. What you need to mainly know about this section is pretty simple. Honestly, we're going to be looking at whole numbers, which, remembering that a whole number has an invisible decimal behind the ones place that we can't see always, but we know it's always there. Just remember that. The decimal is always there, whether we see it or not, kind of like Santa Claus, always there. So with our whole number with our decimal in the back, we're going to be looking at changing our whole number to 10 times that amount or 1/10 of that amount. So let's look at how this looks in practice, alright? So if you look at the board, you will notice the number 30, alright? Regular old whole number. Think about it, guys. Where's my decimal going to be in this whole number? You're right, it's going to be right there. Whether it's there or not, it is there. Whether I have it written on the board or not, there is an invisible decimal behind every whole number, which is kind of cool. So if the question or the problem asks you to identify what 10 times this number is, so what do you think we're going to be doing? Obviously, 10 is a whole number, right? And a whole number times a whole number is going to give me a larger whole number. Right? 10 times as much as 30 is going to give me a bigger number. Make sure you have that in your notes. Now on the flip side of this, we have 1/10 of a number. 1/10 of a number. Now I know from 4th grade that 1/10 is a fraction, right? Not only is it a fraction, I know that a fraction is less than a whole number. It's less than 1, right? It's a part of something. It's a piece of a pie. It's a part of a cookie. It's something that's been cut up and is represented by a numerator and a denominator, correct? Because I'm looking at 1/10 of a number, of my number 30, with my invisible decimal behind it, right? 1/10, if I'm asking you to find 1/10 of that number, you will be identifying a number that is going to always be smaller than the number that you started with, than this 30. So following the same idea, let's see if we can identify what number is 10 times the size of 30, as well as the number that is 1/10 the size of 30. There's a couple ways that I can do this. I could choose to actually do the multiplication out, and I can multiply 10 times 30 and figure out what that product is, because it does say times that number. Use that invisible decimal that we have here that lives behind every whole number and use that to our advantage. It's there. Why not use it, right? So what we can do is we can actually take this, and I know in my brain as a 4th grader, now in 5th grade, having had 4th grade math before with Miss Jones, Miss Purdy, or Miss Moore, that I can take this decimal and I can make it bigger. I can make this number bigger by taking this and bumping it one place value to the right. I know in order to make a whole number bigger, I move it to the right. So I take that 30 and I move it to the right. Now the problem is, how many place values do I move it to the right? Well, here's the cool thing. I only move it one place value to the right because I only have 1 0 in my number here. So I'm only making my number 10 times the size. I take my invisible decimal and I bump it once. With that, I now have my decimal here, and I fill it in with a 0. So according to our rules that we have over here, 10 times a number gives me a bigger number. Well, 300 is definitely bigger than 30. And I move my decimal to the right one place value for every 0 that it is asking me in my problem. It followed the rules and we got the right answer. Now we're not going to be making our number any bigger. Now we're going to actually be going the opposite direction, doing everything we just did, but in the opposite direction, and making our number, yep, go ahead, say it. We're right, smaller. We're going to be making our number smaller, because as we said before, 1/10 is a fraction. So it's only a part, it's only a piece. I want to take this whole number 30, and I only want a piece of it, a part of it. I only want 1 out of the 10 pieces of it. So for every 10 pieces, I'm only going to eat 1 of them until I get up to 30. So that's what we're going to identify now, okay? We've already made our number bigger. Now we're going to work to make it smaller. We're going to be making it smaller. So in order to make it smaller, you're right, we have to move in the opposite direction. So if I'm moving it right to make it bigger, I'm going to have to move it left to make it smaller. Absolutely. For sure. And just as I said before, if we are moving it one place value because there's 1 0 here, well, guess what? We can still use that, because here my 1/10, my 10 only has 1 0 in as well. That should be a clue in your brain to only move it one place value. So I'm going to start with my 30 with my invisible decimal behind it. And again, I'm still doing the same exact thing. I'm going to be moving it 1 decimal place value, but instead of moving it to the right, because I want to make it smaller, and moving it to the right will not make it smaller, it will make it bigger, I'm going to be moving it to the left. Now when I do that, my number is not 30 anymore, my number is now 3. I have 3 decimal 0. If I was in 4th grade, also in 5th grade, we would read that as 3 and 0 tenths, because that 0 is sitting in that tenths place value. Now looking at this table that I made, it has across the top 10 times and 1/10 of. Going down, you can see different numbers. We're going to fill in this chart answering those questions. So 1/10 of a number is always going to give me a smaller number if the number is a whole number, and 10 times as much as a number will give me a bigger number than what I started with, as long as it is a whole number, which is what we're working with right now. So as I said before, behind every whole number we have an invisible decimal, which is kind of cool. So I'm going to insert my invisible decimals, even though I don't see them. We can always write them in, which is kind of fabulous, not gonna lie. So because I know I'm going to be moving 10 times as much as 60, again, I can do it the long way and do 60 times 10, or I could simply bump my decimal 1 place value, because I know that that's what that means. I know 10 times a number is physically moving that decimal place 1 place value. So when I move my 60 with my invisible decimal 1 place value, just move that decimal straight over, like he's doing the cha-cha slide or something. Fill it with a 0, that's my answer. So 10 times as much as 60 is 600. I can quickly check that by saying, is 600 bigger than 60? Again, looking at my 1/10 of, I know that I'm looking at my 60 right here, and I'm going to say, what is 1/10 of 60? I know my answer should be smaller. Again, I use my invisible decimal, and I bump my invisible decimal 1 place value to the left, because that is the only way to make it smaller. When I do that, my decimal now lives between my 6 and my 0, giving me 6 whole or 6 and 0 tenths. Quickly doing it for our second problem here, 310 times should give me a bigger number. I'm going to, in my brain now, because I see the pattern here, and I'm going to whoop, bump that over. So I know I'm going to have 300 plus 1 extra 0, giving me an answer of 3,000. Again, now my 300 is going to become smaller. It's going to become 1/10 of what it originally was. In my head, I know that I bumped that decimal place over 1 to the left, giving me 30. This is a very valuable skill that you will see over and over and over again this year. Throughout the year, we will do it with whole numbers, fractions, decimals. We will do it pretty well till we are blue in the face.